My name is Francois Martel. I'm field CTO at Newberg, and we are building a teammate for SREs. And SREs don't do just one thing, of course, right? And that's part of the problem, I think. But so there's going to be a lot of SRE teammates that are using AI to help SREs. So I'll really focus on what we're doing, which is the helping SREs do root cause analysis. Okay. So with that, let's get started. So anybody know what this means? Don't worry, my presentation is not all in Yiddish. I don't even speak Yiddish, but or is it? I think it's Yiddish actually, but it means man plans and God laughs. And if you know the software gods, they have a pretty sick sense of humor. And so when SREs plans, God's gonna hold my beer. So the story that the reason why I'm bringing this up is the whole SRE concept started 20 years ago, roughly. And it was all about reducing toil. And the E in SRE is pretty much half of the job description, right? Originally, we were going to be engineering our way out of the toil. And it's not like everybody that's an SRE does the same thing. That's what I'm learning in my job, talking to a lot of organizations. They're like, oh, do you have an SRE team? Oh, we're not really an SRE team. And there's like multiple people involved. So when I say SRE, it's a whole group of roles, right, that collaborate to help ensure that the reliability is achieved, right? And so a lot of that has to do with operations, being on call, and unfortunately, a lot of what happened over the last 50 years, as we started, we had our SRE over here, and he had just like one dashboard and some logs, and then started using that 50% of the time to engineer and started creating things like Kubernetes and CI/CD and DevOps and infrastructure as code and observability. And things started getting a little more complex because now what do? We mostly manage those things that we created, and cloud got more complex. And really, the beneficiary of all this are the developers, right? And now the developers have AI and they're just shipping more and more code. And so that's like why we, as an SRE community, we have to get our own AI so we can keep up with those developers. We gave them all the tools to create microservices and all these complex dynamic systems. And now we're stuck handling all the telemetry they're emitting. And this logo might not mean anything to you, but basically it's the logo I found to describe AI ops. So AI ops was the first wave of just like, how do we deal with all this alert and metrics? And maybe we have machine learning that's going to look at patterns and try to help us out. And what it actually did was just give us one more thing to manage. And it didn't really deliver on the promise. And we're still stuck here with all these alerts and overwhelmed and stressed. And we got to, once again, engineer our way out of here, right? And this is just some third-party validation of what I'm saying, but basically a lot of observability out there, right? You've got so many observability platforms because I used to sell 12, 15 years ago one of the first APM solutions. And what my observation then is like people that buy those tools, they always buy the next tool. They always are going to buy more and more tools because it's never good enough and you always need more visibility. And so we've ended up with a lot of fragmentation, right? You've got Prometheus over here, CloudWatch, Datadog, Grafana, and everybody's got on average 4 to 5 observability tools. And of course, Datadog's coming in and saying, hey, you should consolidate all your tools on the best one that costs the most. And that'll solve all your problems, right? There's a lot of teams that use different tools and you have to stitch it all together, right? And so what we are doing is we're helping SREs. We're not an observability tool. And before I introduce Newberg, like I'm curious here, who does some of this where you're like in your observability platform, getting some logs and metrics, and then swivel chairing to, you probably have just two tabs on your browser, but you have ChatGPT or Cloud over there that's helping you understand what you're looking at, make sense of it, maybe helping you generate queries. A lot of the observability tools are providing these chatbot type interfaces. Maybe you have a chatbot that's connected to your knowledge base, Confluence, where you can search for information and get help, right? Anybody doing this? It's a great start, right? It's very helpful to have these LLMs that are super knowledgeable. It's helpful when they're connected to your knowledge base, but you still have to go back and forth, and there's no automation there basically. And so the basic premise of what we're doing is shifting this around where you provide your knowledge, right, to the AI, and you connect your AI to your knowledge base and to your telemetry, and it goes and does the research for you, right? And so that's the fundamental shift that we're trying to bring. Is people call this agentic AI, right? So the agent here has a set of knowledge, it has a set of connections to data, and it knows how to connect the data, run queries, analyze the results, and automatically go to the next step like a human would. Okay. So that's what I'm going to show you, is a demonstration of this concept. And of course, the devil's in the detail. And so you want to be able to do all this in a secure way, where if you went to your security team and said, I want to connect all my data sources to my LLMs, they'd be like, whoa. And we get that a lot. I'll explain a little bit after I show you how it works and what it does, a little bit how we keep your data safe. So the demo scenario is pretty straightforward. Anybody ever used the EKS workshop? So it's a sample application and workshop that Amazon publishes, and you can go and learn about Kubernetes. So it's got some microservices that are backed by some data services over here. It's got a front-end user interface, and there's a card service that we're going to modify in the demo. So we're going to use Jenkins to run a pipeline after a code commit that's going to update the config map for the card service and set the create table to false. And because it's a demo environment, there's no PVCs behind these things. DynamoDB is going to restart and the table won't exist, and we'll get a 500 on the front end. Okay, so there's an alert, and now I need to go figure out what happened, right? I get, in this scenario, the way we've automated it is you've got your application, it's deployed in EKS. You've got Amazon CloudWatch getting the logs. You've got Prometheus getting the metrics, and then Alert Manager raises the alert. There's a 500 or too many 500s on the UI. That goes to PagerDuty, and PagerDuty is integrated with Hawkeye. So Hawkeye is our SRE, okay? That's the name of the product, if you will. And then this will go and investigate the incident. Okay, so I have, keeping with my theme of gods laughing when we make plans, I'm not going to tempt the demo gods. And so I recorded all this. So the end game is basically, think of most people that have any sort of on-call duties, right? They cannot keep up with the volume of alerts, right? And every time they have an alert, most of the mean time to resolution is spent with the alert waiting for somebody to look at it. And then that person looking at it, going to all the dashboards and going through the stack and understanding the application and trying to explain what happened. And then when they've explained what happened, then they go fix it, right? So what we're doing is giving you a head start so that the explanation of what happened is available to you when you go look at the alert. Okay, so compressing that timeline so that you can keep up with the alerts. Now, eventually, the AI will be good enough that will actually go and fix some problems automatically. That's not what we're doing today, but you can understand that's the vision, right? So today we'll recommend the remediation and I'll show that. Yes, exactly. And also, who here likes to write RCA documents? Oh, this guy over there. He's in product management. Yeah. And so we'll help with that too, right? So it's really, that's the vision. So here's our application. I'll pause this once in a while, but basically this is Yali, which I think is awesome. I just learned about it recently, but it's pretty cool visualization of our application here. So we have a UI. The UI service calls the cards. The card service is over here. And then we've got the catalog service and everything is running fine. The UI is working. And then somebody, the scenario is obviously manufactured. Somebody decides I'm going to change this config map to not create the Dynamo DB table. And that's going to kick off a Jenkins pipeline after I commit it, right? So I'm adding it to my GitHub, and then I have a GitHub workflow or that. Anyways, no, Jenkins is actually connected to my GitHub repo and is going to deploy this change to my production system. So as this happens, obviously there's logs that are going to be emitted. Hawkeye can actually also connect to GitHub, right? So the idea is that we're not just looking at your metrics and logs, but we're looking at the big picture, right? We can correlate what's happening with the 500 with this action that somebody just took, right? Oh, there was a Git commit, the pipeline ran, the thing started failing, right? That's the goal. So here we see Jenkins, the pipeline succeeded. Obviously, this is accelerated. This is the video. And now my application is going to start failing, right? So I've got my 500 error and I need to go solve this problem. And so we'll see this is going to turn red and so if I'm on call and I'm being brought into this, it's the old challenge of my alerts over here on the 500 because that's where my alert is configured. A lot of the problems we see is that how do you know that your alerts are configured right? So we're working on that part of the problem is coming in the future where why doesn't the AI just go look and set up the alerts itself, right? That's, you can think of the vision of you should have a goal and then the alerts could be dynamic eventually, but here we're relying on the observability and the alert being set up. But now I need to go find out the root cause. And my alert is just, I've got a UI 500 error. So this is Hawkeye. And again, there's a couple of ways to get Hawkeye to start investigating. So you have this user interface here and you can come to our booth and we'll give you a bunch of demos. But you can basically come and ask questions, okay? And these could be open-ended questions. And again, we can connect to your logs, your metrics, your configuration. So we can actually go look at your Kubernetes configs, your cloud configs, your security groups. And so you can ask it things like, hey, can you review my environment for security gaps, right? Or compliance, or you can ask open-ended questions like that. It's really, think of Hawkeye as an investigator that knows how to navigate all this information it has access to. And so here we're asking it to investigate this 500 error. And we're just providing this context that there was a Jenkins pipeline and I got a 500 error and go try to explain what's going on. And so what happens here is this agentic flow. And what you're going to be seeing is the LLMs are being used by Hawkeye to reason about the problem. We present the LLM with a abstracted data virtualization layer of all the logs, metrics, configs, GitHub actions, all these data points that we have access to. We create a virtual schema over that. We present that to the LLM, and then the LLM writes a program, right? So we're using LLMs to write code in real time to go process all this telemetry. And what you're seeing here, it goes pretty quick, but basically It's found the right log group in CloudWatch that maps to that UI service. It's found the cart service exception. There was an exception calling the cart service. Then it went to the cart logs, and it found here that trying to move this, and okay, so you see here, it found that there's a, this is the UI service, right? So it's found that the calling the URL, the carts, there was error that were consistently happening, abstract error exception handler in the UI service. And then from here, it's always quoting its sources. Is it playing? It's always going to quote its sources right down here. And then you see it could actually, you can go look at the source information, right? So it's not hallucinating. This is actually fact-based, and it's very accurate and deterministic, because we're not just jamming a bunch of logs into an LLM. We're writing programs to process those logs and using the LLMs to reason and write those programs. So it's very deterministic and efficient. And so eventually, you see here the plan of research that it's going through. And so you see the second step in the plan was to go look at the container logs for carts. That actually dynamically changed midstream, right? Because it found the error in the UI logs that pointed to the carts. So then it decided, oh, I'm going to go look at the carts logs now. And so it went through this whole process and eventually wrote up this analysis. And so you see, here's what I found. The UI service 500 errors caused by DynamoDB configuration issue in the cart service. A recent Jenkins pipeline deployed a change to the environment variable true to change the variable from true to false, preventing the cart service from creating the required DynamoDB table. All this happens automatically while you're not looking. You come into the picture and you have the whole explanation, and you can just take the action that it's recommending. And so I've got the rest of the video is just going to show the user actually taking that action. So we're going to go fix the problem and bring the site back up. So now's a good time maybe for questions. Or SRE, actually. That's the idea. Like here, yeah, exactly. So in the video, you might have noticed that I asked the question in a prompt there. So there's two ways that the investigation can start: from that prompt or from a incident management integration, right? So we integrate with PagerDuty. So in this demo environment, I didn't have PagerDuty, so I manually did it. But we integrate with PagerDuty, or actually there's a third way. We have an API that you can use to create these investigations. And all you really need to do is provide the right context. So very important to provide the time range, the time of the event. And alerts, turns out, are really great context for investigations. So that's basically the basic idea. You have an alert that has all the context, and the investigation starts automatically. And I can show you, this is the actual investigation here that happened. And I can go here and then create a RCA. So once I learn, oh, there's an alert, oh, Hawkeye already investigated. I come here, I review this, and then I generate my RCA. And did I miss it? Sorry, I've got the floating windows. Yeah, here it is. And then I can take this RCA and check it into wherever my RCAs need to go. And obviously here it's formatted in Hawkeye Newberg template, but you can imagine you can write your own prompt engineering to create your RCA in your format, right? So here the scenario is very much a Kubernetes scenario, but this is applicable to a lot of domains. In fact, like one of our initial customers, they tried this with backup management. And we were like, backup, Commvault? Like, is Hawkeye going to be able to do that? Yes, because we use the same LLMs that we all use here, and they've been trained on all public docs for all software out there. So they know about these things. And really, what Hawkeye really knows how to do is follow the facts, right? So how do I get the error message, find it in the logs, find other things that happen at the same time? Same thing that you would do as somebody with a lot of experience finding the root cause of problems, right? You don't need to necessarily know everything about the application you're trying to debug. You just are really good at following the clues, and there's some basic principles that you apply. Any other questions? Yes, great question. Thank you. So the question was integrations that we have. And so if you go to Hawkeye here, you'll see there are multiple types of connections you can make. So when you create a connection, you've got the two main clouds. We're adding GCP, but most of our customers on AWS or Azure. When you connect here, you're really providing a role ARN, and that role ARN has read access to whatever you want to give us. So CloudWatch logs and metrics, traces. Also, we can actually look at the cloud configs, right? So we can look up the security group and things like that. Similar thing with Azure, where we have Azure Monitor and everything in that Azure Monitor ecosystem. So Prometheus, that's managed by Azure. We have a lot of incident management system. We're adding Jira, but we have a ServiceNow and PagerDuty here. GitHub. So we're not reading your code, but eventually, why not, right? I think actually, honestly, there's going to be multi-agent workflows in that space where maybe you have an agent that's ingested your whole code, has ragged it and understands it, and then we're going to just call that agent and say, hey, this is happening in production. Can you tell me, like, this last Git commit that I saw, what's happening here? Do you have something that could explain what I'm seeing? So I do see this, but we have GitHub here, Datadog, Azure DevOps, right? So we're not just one type of connection. We're adding more and more. We're going to be like, we get Kubernetes config information through the cloud APIs right now, but we're adding kubectl, right? Like, why not? The LLMs can get information, and from kubectl, we've got Elastic, Prometheus. So a big part of what we do at Newberg is really think through how do we achieve accuracy, right? No hallucination. How do we do all this usefulness, right? Accuracy, usefulness, without breaching any kind of security risk, right? Nobody wants to send all their logs to OpenAI or Anthropic. And I won't go through all the nitty-gritty details here, but this is on our doc site on how Hawkeye works. And the key that I want to let you in on, the key aspect is that we are writing code. The LLMs are mostly writing code and reasoning for us, and we're executing that code. So when you're all these data sources, they plug in through our data access virtualization. So we're presenting the data in an abstract manner to the LLMs. The LLMs writes code against those data sources. We have a code execution engine that goes and runs the code on behalf of the LLM and then provides abstract results back to the LLM, right? So the LLM is going to say, hey, do you see logs around that time with this keyword? Yeah, we see that. What else do you want to do? Look for this pattern. Did you find that pattern? Yeah, we found that pattern. So this is how we're limiting. If you started sending all your tokens to the LM, your logs, there's a lot of tokens and it would be expensive, but it's also a security risk that nobody wants to take, right? And so this is our approach, is using the LLM's reasoning power and then creating this agentic flow that can converge and provide useful, accurate results. And then the game is, okay, what else could we tap into? Over time, we're going to be adding more and more command line tools that SREs use in their day-to-day. They'll let the LLM or the Hawkeye use those tools on their behalf.
When the incidents happen, one of the things that our leadership looks for is the notification to them.
Okay.
Are we also notifying? Can we also input email IDs, distribution lists to ensure that as soon as the RC is ready, it also gets sent out to a leadership team, because that's the main thing they want.
Yeah. Okay. So that's a great setup for my last slide, which is it's your data, it's your knowledge, and it's your workflows, right? So this sits here in this workflow category. So we have APIs, we have integrations, we can integrate with this workflow of yours. And so, yes, we can actually do that, but it's not like out of the box, it'll know what your workflow is, right? So that's part of the implementation of Hawkeye is, okay, when do you want to notify? Who do you want to notify? Do we do this using our APIs? Are we going to build a webhook or something like that? So we'll work with you to make that happen. But our vision is a lot of people are going to build their kind of SRE tools on top of us and others, right? Back to my first point, SRE Copilot is a very generic term, but SREs are not just doing root cause analysis. They're doing a lot of things. And so there's a lot of excitement in the industry about multi-agent communication in AI, right? So how does our agent work with your other agents? And so this is one example, is just fitting into your workflow. It's not a black box that just does what it does. Like we integrate with your incident management system, right? Those things are not going to go away. We integrate with your observability tools. Those things are not going away. We're just going to go and fit into your workflow and your landscape.
Yeah. One more question.
Go ahead.
As far as RCAs are concerned, we also provide like what we could have done to avoid this. What are the problem statements that we have? Does
Okay.
it also provide any custom industry-wide recommendations that you should do this to avoid such scenarios?
Yes. When you find the root cause analysis in the UI, you can ask follow-up questions. So that's an example of just, you could ask this question, right? So it's not if you go to the UI and you look at the RCA page that I showed you where I generated the RCA, there's a way to go look at what it did, understand the chain of thought, how it got there, look at all the data, and ask follow-up questions. So that's where you would do that.
Okay.